The energy sector is directly linked to economic and social development. Various countries continuously aim at providing and securing their energy needs because economic growth requires additional energy supply. The rates of energy production and consumption of economic growth varies from one country to another. In Jordan, demand rates for petroleum and electricity increase continuously, causing a heavy burden on the national budget due to the fact that 96% of consumed energy is imported. Therefore, it was necessary for Jordan to formulate a national energy plan, which aims at relying on local resources and on decreasing imported energy. Efforts are made to find additional indigenous energy resources through exploration and mining, and through adopting a policy to utilize various energy sources such as oil and gas, nuclear energy, and renewable energy. The energy plan includes the transfer of advanced technology, research and development activities, and the supply of specialized human resources in the various energy fields. Relying on studies and research conducted by the Natural Resources Authority, specialists predicted the presence of uranium in the central Jordan region. This prompted the government of Jordan to conduct further studies and to increase the prospecting activities in this region. Such efforts resulted in proving the presence of moderate quantities and concentrations of uranium ore that can be extracted and then exported to be used as a nuclear fuel around the world. The utilization of this ore is in line with the National Energy Plan that calls for increased reliance on local energy sources. This led to the establishment of the Jordan Atomic Energy Commission and the Jordan Energy Resources Company. The Jordan Energy Resources Company was established in 2007, fully owned by the government of Jordan. Its main objective is to prospect for and discover additional uranium and other nuclear minerals in Jordan. Uranium is the basic raw material for nuclear projects. Natural uranium is composed of three main isotopes: U-234, U-235, and U-238. Uranium-238 constitutes 99.3% of natural uranium, while the percentage of U-235 is only 0.7%. Uranium is used in research studies, medicine, agriculture, and industry. Uranium-235 is used as a nuclear fuel after its enrichment by raising its ratio from 0.7% to 4%. Nuclear fuel goes through the fission process when bombarded by slow neutrons. Uranium ores are present in nature in large quantities, but in very low concentrations. It is present in the Earth's crust at 3 grams per ton and in seawater at 3 milligrams per ton. Few regions in the world contain moderate to high concentrations of uranium ores that make them economically viable. The economic feasibility of uranium exploitation increases with higher concentrations. Uranium was discovered in central Jordan in 1993 in Khan Zbib, Swaga, Aqarat al-Ghadran, and Wadi al-Maghar areas. This deposit is currently subject to a detailed exploration conducted by a specialized international company. Specialists at the Jordan Energy Resources Company have collected and studied the available technical information to identify the locations and the concentrations of uranium ores in several locations in Jordan. These studies depended on the results of the airborne spectrometric survey conducted in 1980, which indicated the radiometric anomalous areas in the kingdom. These specialists also depended on the technical reports of the studies related to exploration results in the south and middle parts of the kingdom. The available geological and radiometric maps were also used. The company's technical team discovered additional uranium resources with an average concentration of around 150 grams per ton in the vicinity of Al-Hassa and Al-Abyad. Prospecting efforts will continue to cover all Jordan for the purpose of producing an atlas indicating the locations of uranium and other nuclear materials. Furthermore, there are additional heavy minerals in the south of Jordan, including zircon, titanium oxide, thorium, and rare earth elements. The Jordanian phosphate contains around 60 grams per ton of uranium oxide. Currently, the 6 million tons of phosphate produced annually contain around 360 tons of uranium oxide. The estimated phosphate reserves of 1.7 billion tons contain around 100,000 tons of this oxide. Uranium exploitation requires specialized experience in exploration, mining, processing, and marketing. It also requires a large capital and considerable operational expenses. Since those requirements are not currently available in Jordan, the Jordan Atomic Energy Commission and the Jordan Energy Resources Company have selected a specialized international company to be a strategic partner to exploit uranium in central Jordan. The uranium exploration program involves the use of airborne radiometric survey results and available geological information. The location of uranium ore is delineated using specialized equipment. Then, boreholes are drilled, trenches are opened, and ore samples are taken and tested at the laboratories of the Jordan Atomic Energy Commission in order to determine the concentration of uranium and other accompanied minerals. After the determination of the resource estimation, tests are conducted to select the proper extraction method. At the end, a techno-economic feasibility study is conducted to determine the viability of the project. When the economic feasibility is positive, open pit mining starts and the extracted ore is placed in large heaps that are subjected to alkaline solutions containing sodium carbonate and bicarbonate, which dissolves the uranium. The resulting solution is then collected and pumped to the processing plant, which removes impurities and produces yellow cake that contains around 80% of uranium oxide. This yellow cake is then exported in order to be used to produce nuclear fuel. The uranium ores discovered in Jordan are considered to be important economic assets. Studies indicate their presence in moderate concentrations and quantities. Uranium exploitation is considered an important project for supporting the economy for the coming years, especially when Jordan relies heavily on importing 96% of its energy resources, the prices of which are constantly increasing, causing an obstacle to the economic growth. World demand for uranium increases notably every year, and the demand is expected to increase by 146% by the year 2030. This will cause an increase in market prices. The heat generated by 1 kilogram of nuclear fuel enriched at 4% is equivalent to the heat generated by 168 tons of coal, or 88 tons of oil, or 103,000 cubic meters of natural gas. The cost of nuclear fuel consists around 5% of the operational cost to produce electricity. This ratio is several times higher for power plants that use oil or gas. Thus, the cost of kilowatt-hour of electricity produced by nuclear power plants is much lower than that produced by other fuel sources. The operations of uranium mining and extraction are similar to those operations of other minerals. Therefore, they do not impose any more harm to people or the environment. The workers on the site or people living near the ore mine are exposed to radiation levels that are much lower than the maximum allowable 2,000 millirems per year per person. Every person is exposed to natural radiation at a level of around 300 millirems per year. This radiation comes from space, soil, water, plants, and people. This number increases with the increase of height above sea level. A worker in an open-pit uranium mine is normally exposed to the average of 160 millirems per year of radiation. This amount is equivalent to only 8% of the maximum allowable level. A worker in the uranium oxide yellow cake extraction plant is normally exposed to the average of 600 millirem per year of radiation, and this is equivalent to 30% of the maximum allowable level. A person is also frequently exposed to radiation from medical sources, such as X-ray and CT scan tests. The amount of radiation exposure to such medical sources varies between 12 and 2,000 millirems for each test per person. The radiation level exposure from uranium ores or from yellow cake are very low and do not exceed 5% of the maximum allowable level. The degrees of security and safety measures taken when dealing with uranium and its utilization largely depend on conformity to the safety measures required for the full nuclear fuel cycle, starting from the moment of its extraction to the end of its usage. These measures aim at preventing any harm to people or the environment. The nuclear cycle starts with the stage of prospecting for uranium ore and then followed by the stage of uranium oxide production. The stages are: 1. Searching for uranium through prospecting and exploration. 2. Mining and transport of ores to the uranium processing plant. 3. Grinding. 4. Separation of uranium oxide from other minerals by using proper solutions. One of the important activities of international uranium mining companies is the rehabilitation of the areas in which uranium was extracted by returning to the mine pit the ore remains before closing the mines. The remains of ores placed in the mining pits contain less uranium concentrations than the original ores. There is no doubt that uranium presence in Jordan is a gift from God. Uranium extraction and export will contribute to the economy of Jordan by adding new financial resources, in addition to placing Jordan among the few countries of the world that export uranium.